Okay, guys, we are about to jump in to notes about finding the area between curves. And I thought we would mix it up a little today with some negative filming. So pardon my hands are going to look a little alien-esque, but we're going to be dealing some colors. So I figured it'd be fun to mix it up a little bit. So we're going to focus today on the area between curves. We've already focused on finding the area under a curve, finding the area between that and the x-axis. But now we're going to incorporate multiple curves. Typically just two. So I'm actually going to start by just drawing a picture for us to help us kind of prepare for what we're going to be doing today. So here is my, and just in case you're curious, this is actually a purple pen. So I'm going to draw my, my graph, and I'm going to use two colors to represent two different functions. So I'm going to use this pinkish color, which is not showing up as pink, as my function f of x. And I'm going to grab another color. I'll use light blue. I'm always excited to see how these show up when I do them under the screen. This is light blue. Another function, g of x. Well, we know how to find the area under the curve, like between f of x to my x-axis, or to find the area under the curve of this g of x to the x-axis, but we want to now find the area between these two curves. Well, if we think about it, if I integrate f of x between my bounds, so why don't we go from a until b? So here's a, here's b. If I find the area, or if I integrate f of x from a to b, that's going to give me the area under the curve all the way to the x-axis. Okay? And then if I find the area under the curve g of x, or I integrate from a to b, that's going to give me this area. Okay? So if I actually want to find the area between f of x and g of x, I'm going to find the area under the curve of f of x and subtract away the area under the curve of g of x, because that's going to leave me with this area here between f of x and g of x. So that's what we're going to be doing today. So if I switch back to my notes packet, we're going to find the area between two curves. We really have three steps each time. The first thing we want to do is we want to sketch our curves, because it becomes really important, like which curve is on top, which one's below. It impacts the order in which we subtract. We need to find our bounds. Sometimes they'll be given to us explicitly, like I gave in the picture before, like a and b, but often we'll be finding the area between maybe vertical asymptotes or between intersection points. So part 2 is going to be to find our bounds. Then part 3 is going to be to integrate the upper curve minus the lower curve, which is what we just talked about before, using the points of intersection and the vertical lines as upper and lower bounds. So this is our goal, is to create this statement that we're going to integrate from my intersection point, or bound 1 to bound 2, of the upper curve minus the lower curve, because when I subtract out the area under the lower curve, that will leave me with just the area between our two curves. So let's jump into number 1. Number 1 says, find the area of one of the regions bounded by y equals sine of x and y equals cosine of x. So let's get going on that. So I'm going to start by, now step 1, which we said earlier, is to draw a picture. So I'm going to jump right in. We're graphing sine of x and cosine of x. So I'm going to graph over 2 pi. That's a pretty common interval for my trig curves. And I know sine and cosine go up to values of 1 and -1. Okay, so I'm going to go down to -1. I'll go up to 1. I have these key points of pi over 2, pi, 3 pi over 2, and 2 pi when I graph sine and cosine. So I'll graph in 2 different colors here. I'll use what I did before. So I'm going to do sine of x in this color here. So if I graph sine of x, I know that sine of x starts at 0, 0, and goes to top, middle, bottom, middle. So you guys can see your pre-calc coming back in. So here's that curve. Okay. And now I'm going to graph y equals cosine of x. Should probably, those are pretty distinct. Okay, cosine starts at the top. So I go top, middle, bottom, middle, top. So step 1 is to draw a picture, which is what we've just done. Step 2 is to find our bounds. Now it told us to find the area of one of the regions bounded by sine of x and cosine of x. And if I were to keep graphing this, I would keep getting these sections that look like this. You can see another one repeated here, but it's just kind of inverted a bit, and we'll keep getting those sections over and over again. But they just asked us to find the area of one of the regions. So we're going to try to find this area that I'm shading in right now. That's our goal. Well, if I'm going to do that, our step 2 says to find the bounds. So I need to figure out where this intersection is happening, and I need to figure out where this intersection is happening. So for step 2, I want to find my bounds. And my intersection points are where these two things are equal. I want to figure out where sine of x is equal to cosine of x. Well, if you think about your trig, we're thinking about which reference angle has the same ratios, and that's going to be at pi over 4. And because of the way we've graphed this, we can say that this is going to be my first pi over 4, so this is going to be in the first quadrant. And then if we think about this a little bit, the next time sine and cosine have the same sign as in the third quadrant, so I want my pi over 4 in the third quadrant, which is going to be 5 pi over 4. So now I can jump into step 3, which is actually where I'm going to find the area between my curves. And we said we're going to integrate the upper curve minus the lower curve using my bounds. So I'm going from pi over 4, because that's where this region begins. So right here, we've got pi over 4. I'm going to go until 5 pi over 4. That's where this intersection point is. Okay. So this is here. And I want my upper curve. Well, the way I have this, you can see that my pink is the top curve. So it's going to be sine of x minus my lower curve here is the blue. So, or sorry, for you guys, I guess it looks more orange, is cosine of x. Okay, now I'm just going to evaluate. So let's go through. So if I integrate sine of x, I'm going to get negative cosine of x. If I integrate cosine, I'll get sine. And then I'm evaluating from pi over 4 to 5 pi over 4. So now I have negative cosine of 5 pi over 4 minus sine of 5 pi over 4 minus negative cosine of pi over 4 minus sine of pi over 4. And one of the things I noticed on your guys' test is a lot of you guys forgot to put brackets or parentheses around when you plugged in the second bound. Be careful, because you want to make sure that's negatives getting distributed to both of those terms. So now we can start evaluating. Okay, I've got cosine of 5 pi over 4. Cosine of pi over 4 is root 2 over 2. I'm in the third quadrant, so cosine will be negative. So it's a negative, negative, so I'll be root 2 over 2. Minus sine of pi over 4 is also root 2 over 2, and the third quadrant will be negative, so we're adding it again. Minus. Okay, so cosine of pi over 4 is root 2 over 2, but it's minus. Sine of pi over 4 is also root 2 over 2, but it's because we're subtracting here, it'll be negative. So if we think about what I have here, I have half of root 2, and I have half of root 2, so really what I have there is root 2. I have half of root 2 and half of root 2, but we're subtracting them, so I have a minus root 2, but I'm subtracting a negative root 2, so I have a plus root 2. So my final answer is 2 root 2. Okay, so that's how I found, that's the area between these two curves. So let's jump in and do another one. Number 2. Find the area of the region bounded by the graphs of f of x equals 2 minus x squared and g of x equals x. Well, just like before, we actually want to graph this because we need to know which curve on top and which one's on bottom. So step 1 is going to be to graph my curves. So if I start thinking about what these are going to look like, this is going to be a straight line that's just going to go right through the origin with a slope of 1. This one first. X squared is a parabola. It's negative, so it's going to be flipped upside down, and it's going to be shifted up 2. So I'm going to go up 2. Because my parabola, it opens down, but it doesn't have a stretch. So the pattern for parabolas is when you go over 1, you're going to go 1. So I'm going to have a point here, over 1, 1. And then when you go over 2, 2 squared is 4, so you end up going down 4. So over 2, down 1, 2, 3, 4. Over 2, 1, 2, 3, 4. So there's my parabola. Now, some of you guys might be thinking, Mrs. Barnes, how did you do that so fast? You can always plug in values to get these points. So like if you plug in 0, you're going to get 2 minus 0. So if you plug in 1, you're going to get 1, or 2 minus 1, which is 1. If you plug in 2, you'll get 2 minus 2 squared, so 2 minus 4 is negative 2. So you can also find those points just by plugging it into your function. Okay, so there's f of x. So now let's do g of x. I'll use this color for g of x. Well, g of x is just x, so it's going to be, it goes through 0, 0, over 1, up 1, over 1, up 1, backwards 1, down 1, backwards 1, down 1. So there's g of x. So step 1 is to draw my picture. Remember, I'm finding the area between my curves, so this is going to be the area that I'm solving for. 2 is going to be to find my bounds. Well, we have a couple ways to do this. Option number 1 is we actually see our intersection points. They're really clear. So I can tell one intersection point is at x equals 1, and my second intersection point is at x equals negative 2. But sometimes it won't be that clear, or maybe you're not as confident graphing. So it's also just good to know how to do this algebraically. So if I want to find the bounds or the intersection points, I'm going to say, when does f of x equal g of x? I'm going to get everything onto one side. I like to get the leading term, I want it to be positive, so I'm going to move everything over here. So I'm going to have x squared plus x minus 2. And if I factor that, I'll get an x plus 2 and an x minus 1. I'm looking for two numbers that multiply to negative 2 but add to a positive 1. So I can see that my bounds are going to be at 1 and negative 2, which is exactly what we would have gotten from the graph. So now I can jump into actually finding the area under the curve, which is step 3. I'm going to integrate from my lower bound to my upper bound from negative 2 to 1. And then I'm going to do my upper curve minus my lower curve. Now, I won't always write out this step, but a lot of times on the AP exam, it's helpful to just start by writing, I just want f of x minus g of x. And I can tell that's how I want my order, because f of x is this upper curve for this section. Now, I know f of x over here looks below, but for the section that I care about between my intersections, f of x is the top curve minus g of x. And often you can get 1 point just for setting this up correctly with your bounds, even if you haven't done any other work. Okay? Well, I'm going to substitute this in now. I'm going from negative 2 to 1, and my functions are 2 minus g of x. Now, I was going to do this by hand with you guys, and I know you can do this by hand. Oopsies, I forgot my dx. But I am running out of space, so I will do this with a calculator, as long as you guys promise me that you could do this without a calculator if you had to. So I'm going to go into my calculator. What's that going to look like under the screen? There we go. You can see it there. Okay, so we're going to do math 9. I'm going to go from my lower bound to my upper bound. I'm going to be careful with parentheses. So f of x was 2 minus x squared minus x. It's my lower bound. Looks like my parentheses are all good. Dx. And there's my answer. So that's going to be the area between my two curves. Now again, this is something that you should be able to do by hand, and this is the type of problem that's been put both on calc and non-calculator part of the AP exam. I'm going to stop this video and do part 2 because sometimes my DocCam won't let me film certain length videos. So this is just part 1. I'm going to stop the video and then I'll start back up for the back page for video 2.